Hello everyone, I'm Alfian and today we are going to solve the Leetcode challenge. The name of the challenge is the merge to sorted list, and for the challenge we are given the heads of two sorted linked lists as the name of list 1 and list 2. We should merge the two lists into one sorted list. The list should be made by splitting together the nodes of the first two lists. Return the head of the merged linked list. And this is the example diagram right here. And it has 1, 2, and 4 from the list 1. And for the list 2, it's 1, 3, and 4. It displays as an array, but in real it's form of linked list. And then for the example number 2, both of the lists are empty, so the output is also empty. And for the example number 3, like I said earlier, that the list 1 is empty and the list 2 has the number of 0. Since the list 2 is not null, then the list 2 is being recorded into the output array of nodes right here. And let me remind you again that we are working in a singly linked list and not a usual array like we always work from our earlier videos. And so bear with me. And some people might get confused because it says list, not singly linked list, and they are using an array operation and array functions to solve this particular challenge, and it should have been working with the linked list. And so without further ado, let's work our code right here. Since I am using a TypeScript and the class is already declared here, the definition for the singly linked list and the name of the class is called list node. And for the function right here, merge two lists, the list 1 of the parameter name list 1 is in the form of list node, either list node or just a null value, and the list 2 is also a list node or a null value, and the output we should make the output either a list node or just a null value or the empty array like the one that has been visualized from the example number 2 right here. And so without further ado, let's solve the code. Since it's already declared the list node right here, then we can simply declare our output list node as list node, and then we declare the class called the list node right here. And you don't have to worry about uncommenting this class because it's just a tooltip, and the Leetcode should handle this better than we expected. And declaring list node with the value of 0, and this one variable right here called list node will be our constructor, the main list node element right here from the constructor of the list node, and then we will return this later from our implementation. And I am declaring 0 right here is just a form of dummy node. And then if you look over here on the Excalibur drawing, we are declaring a list node class right here, list node class, and since the first parameter is 0, then we are for the constructor right here, it's the first parameter is considered the value, and since the value is using a question mark right here, and it takes either, since we are using TypeScript, then we can optionally insert a value or not at all as our first parameter. Since we are declaring it, then the value is being recognized. Since it's being recognized, then it takes the number as the type of the parameter right here of the value. Then it should be no other than a number. And for the constructor right here, it takes this dot value, which is the O1 class value right here, as the number, and the next property of either list node or null, since we are not passing the second parameter, which is the next right here, and that takes either list node or null. Since we are not passing it, so the next will be eliminated from here, because we are using the optional, the Leetcode is using the optional question mark right here. And so for this next, it's already undefined. Since it's already undefined, then it is already yes of the ternary function right here. Then it's a null if we are inserting a second parameter of the list node constructor right here. Then the next value is either just the next from the parameter right here as a list node in the form of another list node class. And if we visualize this, it's roughly like this, just a list node class that contains the value parameter of the value property of 0 and the next property of null. And then we can declare another one variable called let current that takes our list node, and for the current right here, it acts as a current pointer to our singly linked list builder right here, and it is pointing right here to the class of our list node right here. And so we can declare another one called the node one that takes the list one, just like the current, or as a pointer to the list one parameter right here. It's because why we are declaring another node one to our list one right here, since list one is a parameter that it's in a form either of list node or null. Then we can simply declare our pointer right here as the current pointer, just like the let of the current variable name right here for the list node that we newly created right here. And so we can declare another one, you guess it, called the node2, and it's equals to the list2, and it acts as a pointer for the list2. So we can iterate the array of list node or between those two parameters right here. And so to begin our iteration, in order to inserting from the list one value into our newly created list node right here, and also for the list 2 inserting into our list node, we can declare a while loop. And while the node 1 is not a null, or using the double pipe sign right here, or the node 2 is not null. If it is, then we can continue our iteration or begin our iteration. So to visualize this, I'm declaring the first test case right here for the case 1. And for the test case, it has, for the list number 1, it has 1, 2, and 4. And if I have to visualize, it's going to be like this, a list node that contains 1, 2, and 4, and it's similar just like an array. And for the second list, which is the list 2, and it's also 1, 3, and 4. And for the pointer right here of the node 1 and node 2, this is the node 1 and this one is node 2. Let me drag this pointer to the respective node to prepare our iteration. since both node 1 and node 2 is not a null and it has the value of the list node class of the value property of 1, and the next value has another list node which is the 2 and 3 respectively, then we can insert our iteration right here after the while loop. You might be asking why I am using the either node 1 is not null or the node 2 is not null. It's because if we look over here for this one, for the second case, which is right here, the case number 2, not case number 2 but case number 3, this one is case number 3, that the list 1 has the list node of null and the list 2 has the node that's just one list node of 0. Then if we declare right here and the list number 1 is null, which is false right here, I am using OR, so the list number 2 node list number 2 is being recognized and will be included in our list node implementation right here. So that is why I am using the while loop of node 1 or the node 2 right here, and then the list 2 of the 0 value right here will be inserted into our newly created list node, and the expected output will be a 0 and not null like this. And that is the desired output from the Leetcode challenge. And for another case, if we look over here, I created a custom. Let me select this. I created a custom list node, and let's say for the node 1 is not empty and node 2 is also not empty, and as we continue our iteration, we are comparing the first iteration, which is node from the list 1 and also node from the list 2, and it is being returned, and 1 is being returned to our list node right here, and then the iteration continues. Let's say the 1b right here is higher. After 1b has been inserted into our list node, then the pointer should move right here, which is the null value, because the next of the list node is already, since the list node right here is already a tail, and then the next property is equals to null and no longer has a list node. And then for the second iteration, list node 1a is being inserted into our list node, and then we are moving to the number 2 right here, to the 2a right here, and then since the list or the node 2 is already empty or null, then it will stop, and we are continue iterating throughout the list A2 and then inserting into our list node. And then for the number 3 value right here, it's also going to be inserted into our list node, and then it just stops right here for the list B. And so the while loop will stop if both of them are already out of the list node right here, so both are returning null, and then the while loop will be stopped. So let's go back to our original implementation. Without further ado, let's solve this by adding an if the node 1 is already null. If it is, like the second example right here, if it is, then we can simply insert our list 2 by creating our current .next and then new list node, creating another list node class that takes the value from the list number 2 of the current iteration, which is the 0, and that we are using node2 using the value property. You might be wondering why I am using the current.next. It's because we are already pointing the current right here from the initial implementation of the function, and in order to get to the next iteration, or to build our singly linked list, we are going to take the next property to chain the next list node to our next property right here. So that's why it's called a linked list. It's a list of nodes of the called list node right here, and we are chaining the next value to our next list right here, and the next is no longer a null, and then the current is still pointed right here, and the list node is being filled with the first parameter right here of the node2 dot value, which is 0. So that's why it is being constructed for the this dot value as the node2 value, and then the value is 0. And then for the next property is also null, and we should move our current to the next, since we are building our list node to be returned as the output of the singly linked list. In order to do that, we can declare our current equals to the current dot next, and then we are using the current dot next, which is right here, the current next from the null right here, and we change the null to the list node number 1, and it's also declared as list node number 1 from the chain right here. And since it's the current dot next, then we are pointing to the next right here, and we are moving to the next list from our newly created list node right here. And not only that, we should move our pointer, since it's already inserted into our list node, then we should move the pointer by 1 by using the, you guess it, by using the node2 equals node2 dot next, just like the one that we declare right here. And we can declare an opposite scenario where using the else if, where the node2 is null. Let's imagine if the list, this one is list number 2 and this one is list number 1. Okay, if the, let's make our implementation right here. Let's implement this. If the node2 is already null right here, then we are processing our list 1 right here, just like we did on the first implementation right here on the first if clause. So you can copy this to save our time, and then it does just the same thing as the one above this, using the current dot next as our list node builder or single linked list builder. And the only thing that changed is the node 1 value. Let me use the Ctrl D to select multiple variable name, the same variable names, and change this, replace it using the node 1. And it does the same thing as we did earlier by on our operation to the list number 2. And then we can add another else clause to check if both are not empty. Since we are already declaring Since I am already explained how the list builder works from combining two linked lists right here, then we can simply add our check by using the, let me move this, let's make the font smaller. Let's declare to check if our, let's say we have 1A and then 1B. We have 1A then 1B. Since 1B takes the precedence, then the result will be 1B inserted into our newly created list node, and then we move pointer B to the number 3 right here, or 3B. Then we can compare 1A with 3B. Since 1A is lower than 3B, then we are using the 1A and then move pointer A. And then for the next iteration, 2A against the 3B. Since 2A is lower than 3B, then we are inserting 2A. And then after that, we are moving to pointer A to 4A. And then for the next one, 4A against the 3B, and the result is of course 3B, since 3B is lower. And then we are moving pointer B to the next one, which is 4B right here. And then we are comparing the 4A with the 4B. And then you don't have to worry about the red or purple which one takes the precedence, since like I said earlier, since it doesn't have any identifier other than just the value of the number or integer right here, so we can just simply use the 4B to maintain our consistency from the 1A against 1B right here. And then we are move pointer B, and then moving pointer B is pointing to a null value or out of bound. And then we are comparing 4A with the null. Of course, we are using the 4A. So let's implement this. Since the last iteration 4A against the null is equal to 4A, it's because we are using this else if clause right here. The node 2 is already null, and we are simply returning our 4A right here, which is the node 1 dot value. And then the linked list builder is moving to the next property, and then the node 1 is moving to the next property, which is finally move pointer 1. And since already on the edge of the list, then it's simply returning null, and both already null and the while loop is stop, and we are simply returning our newly created list node. Let's declare if the node 1, which is the 1A right here, node 1 is higher or equals to the 1B or the node 2. If it is, then we are using the 1B as our node builder by using the current.next new list node, just like we did earlier from the node 1 and the node 2 from the above if and else if. In the node 2, that takes the node 2 dot value, and then we are moving our current to the current.next, and don't forget to move our node 2 to the node 2 dot next, just like we declare right here on our pseudocode. And for the list node number 1, since we are using the first test case right here, then the value is inserted as 1B, and the next is equals to null. You might be wondering why I am using node 1 is higher or equals to the node 2. is just simply to check if the 1a is equals. If it's equals, then it's still returning the b, the 1b. And if it's, let's say if it's 2a against the 1b, of course 1b is also being inserted because 1b is lower than 2a or 1a. So that's why I am using the equals or higher than the node 2. Then we can simply pass the else. If it's the other way around, let's copy this in the current.next. We are not using node 2 and simply passing the node 1 dot value. And let's, after the while loop has been completed, let me visualize this again once more. Okay, so 1a against 1b, the output is 1b. Then 1b is moved, the pointer b is moved to the list node of the value of 3. Then we are comparing the 1a against 3b, and the result is 1a. And 1a, the a pointer is moving right here, and 2a against 3b, it's 2a, and it's moving right here. And 4a against 3b, and it's moving right here. And then 4a against 4b, it's 4b again, and it's moving right here, and it leads to a null value of the next, and it's already a tail. And 4a against the null, which is the one right here, 4a against the null, the else if right here is being triggered, not this one but this one, the else if right here, the else if code block. And then we are simply inserting the 4a, and then 4a moves just like the one piece of declaration right here, and it's moved to the null. Since both already null, node 1 or node 2 is equals to null, then we stopping the while loop iteration. And so after that we are simply returning our return list node. So let's run the code to see if it works. Looks like I'm returning error. And let's make this shorter, since the if and else returning the same thing, the current equals current.next, then we can simply just use once instead of 2, moving right here, and then eliminate our current.next right here, and it also does the same thing. So let's run this again. It's still returning wrong answer, and I think I found the mistake that I forgot to include the value, because we are comparing the value property, not the list node class, the entire class right here. We are just simply comparing the value against one another. So that's why I forgot to insert the value property against the node 2 of the current value property right here. And now it should be working as expected. Let's run this again. It's still returning wrong answer, and the 0 is being inserted into our implementation, and the expected since for the case number 2, since both lists have an empty array or list nodes, then the output is returning 0. It should have been just an empty array. And also the same thing goes to the case number 3. It's also inserting an extra 0 in the front of the list node and the visible one, and you can see the difference on the case number 1 right here. So the 0 is being inserted is because I am using the list node of the 0 right here, but since it's a list node, then our list node right here our list node right here is pointing right here to, let me copy the current pointer. If you look closely of the list node variable right here, I'm using black color. If you look closely on the list node variable right here, it points to the value of the 0 right here, so that's why the 0 is being inserted into the list node right here. What about we are using the current? Because it's pointing to the class or the tail of the list node right here after all of the iteration process from the current.next right here, from from the while loop right here. So let's use this and let's try this out to see if it works. Since current is the one that is always moving around to the next list builder, and the output is only 4, and the one we wanted is the full length of the singly linked list. And for the case number 2, it's returning output of 0. It's because the current pointer is using the 0 as the list node builder right here. Right here, the current is right here for the case number 2. So for the case number 3, and it's returning as expected. What about using the current.next? I think it's returning a null value because the next is always a null, since the current is pointing to the next property, which is null. And the output, of course, the output is a empty array, and as the expected output is 0, since the list 2 has the 0 value. What about using the list node.next? Let's run this to see if it works. And now it's working as expected without the 0, without the one that from the list node 0 right here of the list node.next. You might be wondering why using the .next instead of the current. We already tested. The current is only returning to the tail of the list node, and then if we are using the next property, it's pointing to the null, because since it's already tail. For the list node constructor right here, if it's already tail, then the next value should be null, because we are not declaring our new list node constructor with the second parameter at all. And using the list node.next is returning the value as we expected, other than just using the list node without the .next. If we are using the list node, just list node without the next, then we are including our value right here from our list builder of the 0 value right here, and using the next is ignoring the value of 0 and then it's just looking to the look to the next property right here onwards to the last of the list node, instead of using the value right here. And that way we are simply, in other words, we are simply using the list node of the list node constructor right here just as the list node head and as the dummy list node, and then for the real one we are returning .next and ignoring the first list node head right here. So maybe my explanation is not enough. If you have any questions, you can still ask me in the comment section, and if you have any better solutions or better explanation about this, you can also tell us in the comment section. I hope you have a great day. and I will see you in the next video. Goodbye.